Welcome back, guys. This is the small lab for the cost. We will discuss about how OSPF calculates its cost and how we can change the reference bandwidth and how things are moving in the cost area or the metric area of OSPF. So if you look at the topology is very basic. We have a serial interface between router 1 and router 2. And if I look at the configuration of the interface, you can see that I have one serial and one loopback. Right, nothing fancy, nothing there. If you look at router 2, it will have 3 of them. So 3 of them, one is Ethernet towards router 3, one is serial 1 by 0 towards router 1 and the loopback. And if you look at router 3, you will see that we have one Ethernet and one loopback. And I have a wrong loopback, so let's fix that. 3.0.3.3.255.0. Now if you look at this, now we have the correct information. So now what we need to do, first we will enable OSPF and we make sure that our loopbacks are advertised properly. So let's go back on router 1. Let's enable router OSPF 1. Let's put the router ID like whatever we are doing, and then do the network of 10.1.12.1. 0.0.0, and this is in area 0. Everything will remain in area 0. We are not going into multi-area scenario right now. And then we will also do a network of 1.1.1.1.1 in area 0. Or I can do network 0.0.0, whatever, right? And the other thing, we'll go to loopback 0 and we'll change the network point to point so that we have the proper subnet mask travel to another router. So let's do router OSPF 1 and router ID is 0.0.2 and network. We can do all as I said to you guys, like we can do this within area 0, right? This is sufficient. In this one we will do the same. Now in the second one I haven't changed the loopback, so let's change the loopback. Point to point, and then on router 3 let's do this one quickly, and we can also do the network of all zeros here as well. So there we go, and we also change the network type to point to point. Now we have all of them should have fine. So now if I look at router 1 and if I look at your IP route OSPF, we will see that now I haven't received router 3 loopback yet, so we will wait because 2 and 3 has to become the neighbor. Haven't done so far. They should be in the waiting state. So if I look at your IP OSPF neighbor, they are in start state, so they are becoming neighbor. So once they are full, then I will receive the route. Okay. So let's see when they become the full. Now they think they become the full. Are they? Yeah, they are full now. So let's see, we have received something. No. No, have I? Show IP route OSPF. I'm receiving 3 here. That is fine, right? So let's see why we are not receiving it here. No, we are receiving it here. So we have it here. So you see these costs coming up, right? So how these costs are being calculated, that's what we what the idea, what the mindset is that we need to know, right? If I go on router 2 and we verify, okay, show IP route OSPF, we see that we have a 65 cost for router 1's loopback, right? 65. So now we need to know why this is coming in 65. So we have to go on router 1. First we have to analyze what is the cost of loopback 0. So if I go and do show IP OSPF interface loopback 0, we know that the cost is 1, right? So we know that the point to point network and the loopback 0 is cost 1. So it means that out of 65, 1 is the actual cost of loopback 0. So 64 should be the cost of this link between them, right? So if I go there and do loopback 0 to 0 and by 0, we see that the cost is 64, right? And how we are achieving it is because there's auto cost reference bandwidth in place. So if I look at show run all section router OSPF, you will see that there's an auto cost reference bandwidth which is 100, right? So if we take that 100 and divide it by, and let's first see what is this, right? So what is the unit of it? So if I do auto cost reference bandwidth, the unit is in megabits per second, right? So this is 100 megabit per second. And if you look at, the show interface serial 1/0, you will see that we have 1544 kilobits per second. So we have two options. Either we convert this megabit, whatever 100 is, 100 megabits to kilobit per second, or we change this kilobit per second to megabit per second, right? So in megabit we know it's 1.544. So if I open a calculator and if I say 100 divided by 1.544, we have 64.76, and we do not deal with the what do you say, with this fractions. We only take whatever in whole. So in whole we took 64, and that's what the value coming up there. So it means that the actual value of the loopback, actual cost of the loopback is 1. Now there are multiple ways what we can do. We can say, okay, we want the loopback to be cost of 20. So we can go on router 1 and we can say interface loopback 0, IP, OSPF cost, and then we can define whatever the cost is. So let's say we say cost is 20. So if we say that the cost is 20, and now if I look at the interface of loopback 0, it says the cost is 20. So I'm doing it on a minute level, right? That okay, this has to be cost of 20, and you need to understand how this is coming as cost 1 in the first place. So if you want to go, you can see show interface loopback 0. You will see that the bandwidth is 800 megabit per second, right? So it's 800. So anything divided by 100 divided by 800 will become as 1, right? So the bandwidth is higher, very, very high bandwidth. So our auto cost reference bandwidth will always go in fractions, and for fraction it will take it as 1. Whenever it goes into fraction, it will take it as 1. So that is what's happening here. So now we set it up as our own cost of 20, right? So if we have set up cost of 20, now we have 84, right? Because 64 is the cost of the link, right? And plus 20 for the loopback, which changes to 84, right? Now it goes further to router 3, and router 3 should have received it, because this cost is also need to be added. So this is cost of 10, right? This is cost of 10. So if when router 3 receives it, router 3 should have received it as 94. So if I look at show IP route OSPF, that receiving is as 94, because it has to add the cost of this Ethernet link, which is 10. And if you want to see, you can see show IP OSPF interface Ethernet 0/0, and the cost of Ethernet 0/0 is 10, and that is what being added when it reaches router 3. So this is one method to change the cost, that you go onto the interface and you do it by yourself. And if you do not want to do that, right, then the other method is to make sure that you set the auto cost reference bandwidth value which suits your organization. So whenever you're going to change the auto cost reference bandwidth, you have to make sure that you do it on all the routers which are running OSPF in your organization. Otherwise you will have suboptimal routing, and there will be more issues, and it's hard to troubleshoot what you are doing. So let's say we want to change it. So router OSPF 1 auto cost reference bandwidth, let's say we want to do 1 gig, so 100 meg, and then what it says that reference bandwidth, please ensure reference bandwidth is consistent across all routers. So it means that we have to go here, we have to say router OSPF 1 auto cost reference bandwidth is 1000, which is 1 gig, right? 1000 meg, 1 gig. We have to go here and we have to set it up here, auto cost reference bandwidth of 1000. Now if you look at there's an immediate change, right? In previous OS you have to do it manually. You have to what do you say, you have to restart the process, OSPF process, but in new iOS you don't need to. So if I look at OSPF, now we don't need to, right? So if we go here, show IP route OSPF, show IP route OSPF, and now you look back what's happening with loopback 1, right? So what we are going to do is that, let's say we remove the command what we put there, so no IP OSPF cost 20, right? So now if I look at the actual cost of the loopback, we see that it's still, the cost is still 1, okay? And the reason the cost is still 1, because this guy is 800 meg by 1000. So 1000 divided by 800 is again going into fraction, that's why it's causing it as 1. But if you look at the serial interface, you will see something different, right? You will see that now the cost is 647, and the reason for that is, if we go back here and we do 1000 divided by 1.544, now we have 647 instead of 64, right? So that is that what makes, so the cost is more worse now, right? But what happens is that now router 2 is receiving at 667, do it again, 648, right? Because that is 647 plus 1 for the loopback, this is 648. Now if I go back and change it again, IP OSPF cost is 20, because I want router 1 to advertise it as cost of 20, then router 2 will receive it as what? 648 plus 20 is 668, 667. Yeah, for 647 plus 20, yeah, 667, that is fine. 667, right? And that is again happening with this guy, because instead of 10, now it's the cost of 100, because 1000 divided by 10 is 100, right? So that is how it's happening. And if you go to router 3, this should be coming at 767, because I changed it to 20, right? So whatever the route 667 plus 100 is 767. Okay, so this is but whenever you do that, you have to make sure that you are doing it on all the interfaces. Okay, so I will give you another complex scenario, that let's say you want to make sure that your Ethernet, okay, have a cost of 70. Okay, Ethernet has a cost of 70. So right now, if you look at anywhere, if you look at show IP OSPF interface 0 by 0 on any interface, the cost is 100. Right, so let's do this. Cost. Okay. So this is 100. So let's take this guy. This is 100. Let's take this guy. This is, oh, because this one is not running, so no worries. So how we gonna do that? So remember what the formula is. Formula is whatever the reference bandwidth is, right? In our case right now it's 1000, divided by the bandwidth of the interface, which in our case is 10 megabit. That equates the cost. So now we have two information in our hand, which is the bandwidth of the interface, which is 10, plus we know what cost we want. So we want the cost of 70, for example, or 80, whatever you thought of. Now we just calculate the reference bandwidth, what reference bandwidth we should set to get this value, right? So whatever we set it up, what we need to do is that we need to multiply, because the formula is something like that, right? That the reference bandwidth divided by bandwidth equals the cost, right? So if you take the bandwidth there, then the reference bandwidth is equals to cost multiplied by bandwidth, right? So we don't know the reference bandwidth, but we know the cost will be, let's say, 70 multiplied by bandwidth, which is in our case is 10. right? So it means that if we put the reference bandwidth to what, 17 to 10, 700, right? So if we look at here, 70 into 10, 700. So we put 700 here. Okay. So if you put the reference bandwidth to 700, we will have the cost of 70. So if you do it on all the routers, and I will do in one go, router OSPF 1 auto cost reference bandwidth is 700. Okay. Now if you look at router 2, if you look at the cost, now the cost is 70. So if any time you want a specific cost, you can use this formula and have this thing ready to you. So now if you look at the route, UIP route OSPF, you will see that now it's 543. So that's not 100. So we are coming as 473 plus 70, right? Plus 70 is 543. So this is how you calculate. But remember, you have to do it on all the routers, and usually nowadays you should set it up to at least 1 gig, because now the minimum connection you get is 1 gig, is not Ethernet or fast Ethernet in this case, which is 100 megabit per second, which is set up as an auto cost reference bandwidth. And that is it for the cost, guys. I hope to see you guys in the next lab.